You think electricity is a thing that moves. You imagine electrons flowing through wires like water through pipes. You picture a battery pushing charges forward, one by one, down the line. Slow, mechanical, obvious. This picture feels solid. It feels intuitive, feels earned. It's also wrong.
Not a little wrong, fundamentally wrong. You flip a switch and the light turns on instantly. Not after electrons travel the length of the wire. Instantly. You've been told the electrons move slowly, crawling actually, millimeters per second. So what just happened?
You assume electricity is the electrons, that the motion of charge is the phenomenon, that something physical has to travel from here to there. That assumption is doing more damage than you realize. Because the real story of electricity doesn't feel like flow. It doesn't feel like motion. It doesn't even feel like a thing. And once you see that, the familiar picture collapses, quietly, completely. You were taught to picture electricity as motion. Not just motion in general, a very specific kind. You imagine tiny charged particles inside the wire, packed together, waiting. The battery connects. They begin to move. This feels reasonable. It feels physical. It feels like how causes are supposed to work. Something pushes, something travels, something arrives. So we draw diagrams, arrows along wires, little dots marching in formation. This is the flow picture.
And once it's in your head, it never leaves. Every explanation stacks on top of it. Every metaphor quietly depends on it. But pause for a moment and notice something uncomfortable. No one ever shows you the electrons arriving. They're always already there. The copper wire is already full of charge before the battery is connected. Not empty, not waiting to be filled. So the story can't be, electrons leave the battery, enter the wire, and make their way to the bulb. There is no empty path to fill. There is no queue to join. Still, the picture survives. We say the battery pushes electrons, as if pressure builds up behind them, as if there's somewhere for them to go. This is where the intuition starts to crack, because pushing only makes sense when something can move freely into empty space. But the wire isn't empty. It's crowded.
Every electron already has neighbors on all sides. There is no forward. There is only rearrangement. So what does a flow mean in a place with nowhere to go? The usual answer is they drift, very slowly, painfully slowly, millimeters per second. This is supposed to save the picture.
To say, yes, they move, just not very fast. But notice what that quietly admits. If electrons crawl, then electricity cannot be the crawl. The effect you care about, the light, the heat, the response, happens long before any electron has gone anywhere meaningful. So the flow picture survives only by asking you not to look too closely. It asks you to imagine motion where motion can't explain the timing. To imagine transport where nothing needs to arrive. At this point, most explanations retreat into habit. They say, that's just how it works, much how it works. Or, I don't think about it too much. But this is exactly where Feynman would stop you. Because once you admit that electrons are already everywhere, and once you admit that their motion is absurdly slow, you've already lost the right to think of electricity as something that travels through a wire. You just haven't let go of the picture yet. You flip the switch. The light turns on. Not gradually, not after a pause, not after anything has time to travel the length of the wire. It happens immediately. This is so familiar that it feels unremarkable, but it should bother you.
Because according to the picture you were given, something has to move. The switch closes. Electrons near the switch begin to drift. They nudge their neighbors. Those nudge the next ones. A chain reaction inching forward. But the lamp across the room doesn't wait. If the effect depended on electrons physically making the trip, you would see a delay. Tiny, perhaps, but real? Instead, the response is limited only by the speed of light. That detail is often mentioned casually, then ignored. But it is the entire story. The change caused by the switch propagates through the circuit at nearly light speed, not electron speed, field speed. You don't notice this because your nervous system is slow. Your intuition is slower. Your intuition is slower. So the contradiction hides in plain sight.
The electrons you imagine as carriers of action are barely moving. Yet the electrical effect reorganizes the entire circuit almost at once. So what moved? The honest answer is not the electrons. At least, not in the way your picture demands.
Before the switch, the electric field inside the circuit has one shape. After the switch, it has another. That change sweeps through the circuit rapidly, adjusting forces everywhere at once. The electrons respond locally. They don't carry the message, they receive it.
This is the part most explanations glide past. They treat the field like a bookkeeping trick. a mathematical convenience, but the timing problem refuses to go away. If electricity were transported matter, delays would be unavoidable. If causation required particles to arrive, nothing could respond faster than they move. Yet circuits respond at field speed, not drift speed. So the real agent of change cannot be the thing you were told to watch. This is usually where discomfort sets in, because now you're being asked to accept influence without transport, effect without delivery, a reorganization without a courier. And that feels like cheating. It feels like something non-physical is doing the work. But that feeling comes from the picture you started with. The picture that assumed motion was essential. The switch doesn't send electrons to the light. It changes the rules everywhere in the wire. And the electrons, slow and crowded, simply adjust. Once you see that, the old story can't survive intact. Something else is running the show, and it doesn't look like flow. At this point, the instinct is to ask, then what moves? If it isn't electrons marching through the wire, something must still be going from the switch to the light. Or some influence, some physical messenger. That instinct is understandable. It's also the last piece of the old picture trying to survive, because the unsettling answer is nothing travels the way you think it should. When the switch closes, there is no object that leaves one end of the circuit and arrives at the other. There is no packet being delivered. There is no substance in transit. What changes is the configuration of the electromagnetic field throughout the space around the wire. This is a difficult sentence to sit with, because our configuration doesn't feel causal. It doesn't feel like an event. It feels descriptive, passive. But this is where intuition breaks down. Think about a line of rigid rods touching end to end. Push one end, and the other end moves almost immediately. No rod travels the length of the line. No piece makes the journey. The effect propagates as a pattern of compression, not as transported matter. Electricity works the same way, but without the comfort of visible contact. The wire is already full of charges. The space around it is already structured by electric fields. Closing the switch alters boundary conditions. That alteration propagates outward at a finite speed. Every electron feels a new local force. They respond where they are. No one needs to arrive. This violates a deep expectation you probably didn't know you had. That causes must be carried. That influence requires a traveler. But fields don't work that way. A field is not a thing that goes places. It is a condition that exists everywhere, changing over time. When that condition changes, its change spreads, not as cargo, but as structure. This is why asking what is moving through the wire is the wrong question. Nothing is moving through. What's happening is a global reorganization of local relationships. Each electron doesn't know about the battery. It doesn't know about the light bulb. It only knows what the field is doing right where it sits. And when that local field changes, it accelerates accordingly. This is subtle and unsatisfying because it refuses to give you a single object to point at and say, that's electricity. Feynman was blunt about this. He warned against thinking of electricity as a fluid or a substance or even a thing at all. Those pictures feel helpful, but they quietly replace the phenomenon with a metaphor. Once you let go of the need for something to travel, a different picture becomes possible. Not simpler, but truer. And far less comfortable. At this stage, most people reluctantly accept the word field. They don't like it, but they tolerate it. They imagine it as a ghostly extension of the charge, an invisible reach, a way for one object to pull on another without touching it. This is still wrong, because this picture quietly puts the field on top of reality instead of inside it. The electric field is not a force sent outward by a charge. It is not a message being broadcast. It is not an instruction issued from a distance. It is a local property of space itself. That sentence sounds abstract because your intuition has no place to put it. We are used to objects having properties: mass, charge, velocity. But a region of empty space having a property feels unnatural, so we resist it. We downgrade fields to mathematical tricks, convenient descriptions of what particles do. Feynman hated this move because the field is the thing that tells particles how to behave, and particles respond only to the field where they are, not to distant charges, not to the battery, not to the circuit as a whole. There is no long-range pull, only local conditions. This is why the speed limit matters. When the switch closes, the field near the switch changes first, then the neighboring region, then the next. Each region updates based on what its immediate neighbors are doing.
No region knows the final outcome.
No region reaches across space. Causality stays local. Relativity stays intact. And suddenly the mystery of instant action disappears. Nothing is acting at a distance. Nothing is skipping steps. The field is simply evolving. This also explains something deeply counterintuitive. Most of the energy in a working circuit is not inside the wire. It's in the space around it. Flow diagrams hide this by keeping your attention inside the metal. But the electromagnetic field carries the energy, guides it, and delivers it. The wire merely constrains the field's shape.
This is not a poetic statement. It is a physical one. If you remove the space, the circuit stops working, which means electricity was never in the wire to begin with. Once you accept fields as real, not as metaphors, the entire hierarchy flips. Particles become responders. Space becomes active.
And electricity stops being something that travels and starts being something that exists. That shift is uncomfortable because now reality isn't built from objects alone. It's built from relationships embedded in space itself, and that is much harder to picture.
At this point, it's tempting to throw the electrons away entirely. If they don't carry electricity, if they don't deliver energy, if they barely move at all, why keep them? Because this is where another intuition fails. The mistake isn't that electrons matter. It's how you've been told they matter. Electrons are not the agents of electrical action. They are the medium that responds to it. Inside a metal, electrons form a dense, restless sea. They are already in motion, jostling, colliding, rearranging. Thermal motion alone sends them racing in all directions at enormous speeds. Yet none of that is electricity. Current is not speed. It is bias. When an electric field appears, it doesn't launch electrons forward like bullets. It slightly tilts the statistical chaos. A tiny preference, a barely noticeable imbalance. Each electron still collides constantly, still reverses direction, still behaves almost exactly as before. Except now, on average, there is a slow drift. That drift is a symptom, not a cause. The field sets the rules. The electrons comply locally. This is why increasing voltage doesn't push electrons harder in the way you. It changes the field configuration, which changes the local forces, which changes the collective response. No electron knows it is part of a circuit. No electron knows there is a bulb at the end. They don't cooperate. They simply respond moment by moment to what the field is doing right where they are. This is also why focusing on individual electrons leads you astray. Electricity is not about tracking particles. It's about understanding constraints. The metal lattice constrains motion. The geometry of the circuit constrains the field. The field constrains the forces. Electrons fill in the gaps. Feynman often emphasized this inversion. We imagine particles creating fields, but in practice we calculate fields first and let particles follow, not because it's convenient, because that's how nature behaves. Once you stop treating electrons as tiny messengers, they become something far stranger. They are the compliant background that allows fields to express themselves. Necessary, but not in charge. And once you see that, the last remnants of the flow picture finally collapse. Up to now, the wire has been doing a lot of quiet work in your imagination. It gives electricity a home, a channel, a place to live. Remove the wire, and most people assume electricity disappears with it. This is wrong. Electricity does not require metal. It does not require electrons drifting through a lattice. It does not even require charges to move at all. A capacitor can store electrical energy with no current flowing. 2 plates, a gap of empty space, nothing crossing between them, yet the energy is real. Measurable, recoverable. Where is it? Not in the plates, not in the electrons pressed against the surface. It is in the electric field filling the space between them. This should feel deeply unsettling, because now electricity exists most clearly where there is nothing. No wire, no charge transport. Just space in a particular condition. You can charge a capacitor, disconnect it completely, and walk away. No electrons travel anywhere. Nothing flows. But still, the electrical reality remains. Or take electromagnetic waves. Radio signals carry energy across vast distances with no material medium at all. No electrons drifting from transmitter to receiver. No substance making the journey. Yet energy arrives, information arrives, effects occur. If electricity were fundamentally about charge flow, none of this would be possible. Wires, then, are not the essence of electricity. They are constraints. They shape fields.
They guide how space is allowed to respond. The field does the work.
This is why power in a circuit doesn't move inside the wire in the way diagrams suggest. It flows through the surrounding space, directed by the geometry of conductors. The wire is a boundary condition, not a pipeline. This realization completes the separation. Electricity is not electrons.
Not current, not wires. Those are participants, not principles. Once that separation is clear, one last question remains. If electricity is not a thing, not a flow, not a substance, what kind of explanation are we even allowed to want? That question is where Feynman always ended up. And it's where this story has to end too. At this point, the urge is to ask for the real explanation. Not another metaphor, not another reframing. The thing underneath all of it. Feynman was very clear about this moment.
He warned that this is where people start demanding the wrong kind of answer. They want electricity to be something, a substance, a mechanism, a hidden machine behind the scenes. But nature doesn't owe you that. Electricity, in the end, is not a thing you can point to. It is a pattern in how the world behaves. Charges respond to fields. Fields evolve according to rules. Energy moves through space in structured ways. That's it. There is no deeper picture waiting behind the curtain. And this is deeply unsatisfying.
Because your mind wants a story with parts pushing parts. It wants gears, it wants flow. But every time physics has tried to reduce electricity to something more concrete, the result has been worse, not better. Fluids failed. Mechanical models failed. Little balls carrying forces failed.
What survived were equations describing how fields change and how matter responds locally. Feynman emphasized this not to be evasive, but to be honest. When you ask, what is electricity really? You are often asking for a picture that makes you comfortable.
Physics is not obligated to provide comfort. It provides rules. Rules about what can change. Rules about how fast influence can propagate. Rules about what can affect what and when. Electricity is one of the clearest places where those rules refuse to turn into imagery. The field is real,
But it is not visible, not tangible, not made of parts. It exists the way geometry exists, the way curvature exists, the way a constraint exists. Once you accept that, something subtle happens. You stop trying to imagine electricity moving. You stop asking where it is at a given moment.
Instead, you ask how the relationships are arranged. And that shift matters, because it trains you to see reality not as objects exchanging stuff, but as structures evolving under laws. That is the deeper lesson Feynman was pointing at. Not about wires, not about electrons.
But about the limits of intuition itself. Some parts of reality cannot be turned into pictures without breaking them. Electricity is one of them. And once you stop demanding that it look familiar, you finally see it clearly.